Hello, this is my lab report for Physics 2211, Lab 3. The purpose of this lab is to use net force calculations of a star orbiting a black hole to estimate the mass of the black hole. We're given the mass of the star and the motion of the star. Here are a few fundamental principles that will help us in our calculations for this lab. The change in momentum is equal to F net times the change in time. The change in momentum is equal to the sum of the net force components times the change in time. The change in momentum is equal to the parallel force components times the change in time plus the perpendicular force components times the change in time. The instantaneous rate of change of momentum tells us several things about the motion of an object. The parallel component indicates speeding up or slowing down, while the perpendicular component corresponds to a change in direction. The combination of these components is equal to the net force. I used my email address to create a trajectory for the star. I inserted the mass of the star into the starter code provided. The time between trajectory points in my data is 1 day, so I set delta t equal to the number of seconds in a day. I set the initial and final momentum vectors equal to the star's mass times the initial and final velocities respectively. I made the change in velocity equal to the final velocity minus initial. I made the change in momentum equal to the final minus initial as well. I made the dp dt equal to the change in momentum over the change in time. I made the net force equal to dp dt because Newton's second law tells us that the two are equivalent. I then calculated the parallel and perpendicular components of change in momentum using Newton's second law. I then solved the force of gravity equation for the mass of the black hole and plugged that in to estimate the mass of the black hole. Finally, I inserted arrows to indicate the perpendicular, parallel, and net forces throughout the motion. These are the results of my code. We are asked the relationship between the net force and its components and the change in momentum in its components. The two are directly proportional as stated by Newton's second law. We are asked if we would be able to find a new mass for a black hole if we were to replace it with a different hole of a different mass, but the motion remained the same. We would not be able to because the mass was calculated using net force. If the motion of the star remains the same, the net force will remain the same, giving us the same mass we originally calculated. This concludes my Lab 3 presentation. Thank you.